Hey guys, today we're going to take a look at 10.7 and we're going to take a look at what are called parametric equations. Okay, so this is going to be a little bit different. It's not hard, it's just a little bit different. So if you look over here at this graph, that is obviously not a function. Okay, it would fail the vertical line test, so it's not a function. It's an equation, but not a function. But sometimes it's helpful to be able to look at equations like functions. And so you can do that by introducing a third variable, which we're going to call t. And the reason we use t is because t often stands for time. And we're going to look at this third variable, and then we're going to talk about how this graph changes horizontally in reference to time and how it changes vertically in reference to time. And both of those are going to be functions, okay? Just individually they're functions, and then we can put them together to create the curve or the shape or whatever that we've been given, okay? So down here, if we let x equal f of t and y equal g of t, these two functions are called parametric equations. The t is called the parameter, and that's what we're going to plug into each of these to figure out where our graph is both horizontally and vertically. Now, if you look at this graph, you'll notice that, so here, there's a point here, and then you'll notice these little arrows. So what you want to picture is as you're drawing this out, or let's say, imagine this is some like particle that's moving through space, but there's movement going on here. Because as t gets bigger, think of it as time. Time is going forward, and so that is this graph is getting drawn in a certain order, okay? And that's what those arrows are showing. That's called the orientation of the graph. And we just want to make sure that we show that when we graph these out. So let me do one of these, and you're going to see what I'm talking about. It's probably easier to see than it is for me to try to explain. Okay, so look at the first example. It says graph the curve defined by the parametric equations x equals 3t squared and y equals 2t for t values from -2 to +2. So that's our direction. Okay, so -2 is like our first value that we're going to plug in, and then -1 and 0 and 1 and 2, and that's where we need to stop. Okay, so this is the orientation of our graph. It's going from smaller to bigger. Okay, so I'm going to plug these values into this function first. So x equals 3t squared. Well, -2 squared is 4, and 4 times 3 is 12. -1 squared is 1. 3 times 1 is 3. Then I'm going to get a 0. Then I'm going to get a 3 again, and then I'm going to get a 12. Okay? Now I'm going to put these same values into the y function. Alright, so y equals 2t. So 2 times -2, 2 times -1, 2 times 0, 2 times 1, and 2 times 2. And then together, these are ordered pairs. So 12, -4 is our first value. That's our starting point. 3, -2, 0, 0, 3, 2, and then 12, 4. And that's our last point. That's our ending point. So we're going to start at 12, 1, 2, 3, 4. Then we're going to go 3, -2, 0, 0, 3, +2, and then 12, 1, 2, 3, 4. All right, so our graph starts here. It hits that. It's going to turn, and it's going to come this way. Okay, so this is a parabola. Okay, now we also want to just throw in a few little arrows showing the direction or the orientation of this graph. Notice I didn't put an arrow at the end. This graph doesn't go on forever and ever and ever, so I want to kind of put the arrow over here showing the movement but not making it look like this graph keeps going on. This graph starts and it stops. Okay, that's it. Now, like I said, this is a parabola. You're familiar with that. If you take these two functions and kind of put them inside of each other, okay, so if I take y equals 2t and solve it for t, so t would be y over 2, I could then replace the t in this equation, so x equals 3, and then it's going to be y over 2 squared, right, because t squared, so that's going to be squared. So this is x equals, what do we got here? 3y squared over 4, because that's going to get squared. Now, if I want to make this look a little bit better, I could get rid of the 4. 4x equals 3y squared. Now, the idea is now you can kind of see that we have a y squared and we have an x, and that's a parabola. Okay? So, and the y being squared, that's what makes it a horizontal parabola. So it's an equation, but it's not a function. But we can split it into two functions if we just look at the horizontal direction one at a time and the vertical direction one at a time. So as time goes by, the object can only have one and only one like horizontal location, and so that's why you can break it down into these parametrics. All right, now that last bit where I substituted one function into the other function, that's not something you're going to have to do. All you need to do is take a look at these parametric equations. So x equals the square root of t, y equals 2t, for t values greater than or equal to 0. All right, so this is t, this is x, and this is y. Okay, so I'm going to have a kind of a bigger looking t chart. So the t values, I need to start at 0, and then I want to go bigger. So 0, 1. Now, if you take a look at this function, you're going to notice that we're going to take the square root of t. So I'm just going to jump down to 4. I don't know, maybe a 9. Okay, I'm just going to plug in perfect squares. So do one function at a time. Okay, so just stick with one function. You don't want your brain to have to try to switch from this function to this function to this. Just kind of get your mindset. So we're taking the square root of t. So the square root of 0, the square root of 1, the square root of 4, and the square root of 9. Now we're going to take our t values and double them. Okay, so 2 times 0, 2 times 1, 2 times 4, and 2 times 9. Okay, so that's just the easiest way to do it. And then together, these two columns make ordered pairs. So what do we have here? We have 0, 0. We have 1, 2. We have 1, 2. Oops. We have 1, 2. And then we have 1, 2, 3, 4, 5, 6, 7, 8. Looks like everything else is going to go off the chart. So this graph goes up. It's going to hit that, and then it's going to just keep going. Now this one does keep going. We want all values greater than 0. So this is going to have an arrow on the end, but it's also going to have a couple little orientation arrows showing the direction that we drew it. That's it. That's all you got to do. Okay, so that's kind of like half of a parabola. All right. Last one. Graph the curve whose parametric equations are given and show its orientation. So x equals 2 cosine t and y equals 3 sine t. All right. For t values between 0 and pi. Well, if you look over here, it looks like we're actually going from 0 to 180. So same idea, but this is in degrees. So we're going to have to plug this into our calculators because we need to approximate this graph. So take each of these values and plug them into this equation. So take 2 times the cosine of 0, 2 times the cosine of 30, 2 times the cosine of 45, get that column filled, then come over here and fill this column. Okay? So I want you to try that. I'm going to pause the video, or you should pause the video while you do that. Alright, so if you plugged these angles into the first function, you should have got these values. And then, and again, you're going to notice that we're going from 0 to 180, so these are just in quadrants 1 and 2. So we've got some positives, 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 then we hit 0, and then we go negative because our cosine values are going negative. And then we're just doubling those negative values. So that's what this row is. And then over here, we're taking 3 times the sine of these angles. So again, quadrants 1 or 2, everything's staying positive, but it is also symmetric. So you probably noticed you had like a repeat here, and that may have helped you out. So I want you to try to graph these. So these are ordered pairs. Graph them on the graph that I've given you, and then also show the orientation, the direction that this graph is being drawn. Okay? All right, and this is what you should have got. So what is that? Well, it's like the top half of an ellipse. So you'll notice that from the origin you go out 2 in this direction both ways, but then you go up 3 in this direction. So it's a curve. And if we would have kept going from like 0 all the way to 360, we would have went into quadrant 3. Then we just would have completed the ellipse shape. So that's all you're doing. That's your graph. This is my orientation. So make sure you've got just a few arrows. There's no rule. Just have a 3-4 arrows showing the movement, and that's it. Okay. So take a look at your worksheet and let me know if you have any questions.